Good afternoon. Welcome to sort of the second half of the tutorial day at PyData. I hope everyone is having a good conference. So I'm going to give a quick set of slides, just maybe 10 minutes or so. This is a little bit of a rehash. I did give a talk at SciPy about a month ago, and this is a little bit similar to that. I'm just going to speed through it, though, because most of the tutorial is hands-on exercises. We've got some notebooks, and I'm going to go through some demonstrations and examples there, and then you guys are going to get a chance, hopefully, to work on that as well. So if you haven't, you might try to go ahead and install IPython Notebook. The easiest way to do that is probably to install Anaconda. If you need any help, there are a few Continuum folks, I think, in the audience, and also Mike, another one over here as well, new Continuum person who can help you out a bit. But we'll just wave us over, and I'm going to be coming out in the audience, too, during the exercises if folks need help to sort of get people running. So without any sort of further introduction, let's go ahead and get started. So if you would, let me give you a chance. This is actually the link to the IPython notebooks we're going to use for the tutorial, this bit.ly link. So I'll give everyone just a moment to follow that. It's actually on the NBViewer website. So NBViewer is a website that allows you to host statically IPython notebooks that have whatever kind of content. So there's all kinds of projects, Matplotlib and Plotly and sklearn, all kinds of projects have example notebooks up on NBViewer. So if you just Google NBViewer Bokeh, you probably also find it, or put it in Bing, or put it in whatever search engine you want to. You should be able to find that. But this link should go straight to the Bokeh NBViewer website. Give everyone just a minute. Okay, so everyone had a chance to follow that link and get to the notebooks? Okay, good. So first, just want to talk a little bit about where Bokeh is at today and where it's sort of going. So if you're not familiar, first of all, Bokeh is a plotting library. It allows you to generate interactive, sort of rich and innovative visualizations in the browser, but to do it from Python, really without having to write any too much JavaScript or any JavaScript. And so that's really a nice thing. We've been working on it for quite a while now. We've added a lot of features in the last year or so. So just a quick update on where we are. People have been asking for things like selection tools, lasso and poly, and crosshair inspectors and hover tools that work with lines. All that's been added. We've also done a sort of visual design pass, right? So if you have been following Bokeh for a while, you might remember some early attempts at sort of having a toolbar, and things look pretty clunky, and they look a lot better now. We're still working on that. We're continuing to sort of work on the visual design aspect of Bokeh. Docs, there's a lot better doc support now. People have asked about that. You asked, and we heard that call. So the reference guide is 100% complete. We're still going to be working on improving that with, for instance, like an explorer, a style sort of explorer, an object explorer that lets you in real time in the documentation sort of explore what attributes you can change. That's not quite there yet, but we do have auto-generated reference docs that are automatically filled out. And we also have a much expanded user guide. Let me actually jump over to that right quick, because you'll be spending hopefully some time there during this tutorial. So this is, well, first off, this is the NBViewer site, just so you can see it. And if you go down to the bottom, there is tutorial. And so this is the notebooks we're going to be using. We're going to be using the basic plotting, high-level charts. We'll see how far we get. We're just going to keep working through those notebooks. But if you go to the NBViewer site, all of those are the ones we're going to be using. And then the user's guide, I just wanted to point out, again, this is where we'll be spending a lot of time today, hopefully looking up things. So all the user's guide has information about all the different visual properties, all the knobs and dials that you can turn, and switches you can flip. But it also has live plots with the code examples there. So for instance, how to change the title or the background, or all kinds of things about the glyphs. And so all of these things are there with the actual code samples that generated them inline in the docs. And these are real live Bokeh plots. So hopefully that'll be a useful resource for you. There's a lot of other sections in the user's guide as well. So hopefully this is not the end of the journey for our docs, but definitely I think an improvement that'll be very valuable for folks. Okay. So we also just recently added a new static or a method to add really rich interactions to static documents. And by static documents, I mean something that has the data embedded in it. You could just email it to someone. There's no sort of server required. So we added a mechanism for adding very small little JavaScript callbacks. So we sort of backed away a little bit from the idea of not having to write any JavaScript to the idea that, well, if you don't mind writing a few lines here and there, you can get some really sophisticated interactions without having to need any further sort of server support. So we'll see some examples of that during the tutorial today. And then finally, I just should mention Bokeh as well. So the way Bokeh is architected, it's actually really easy to write, well, it's possible to write language bindings for it in any language, right? It's just a declarative JSON interface. So you can have Scala or Lua bindings have been created. Julia, someone created Julia bindings last year. Ryan Hafen, one of our DARPA collaborators, has started working on Bokeh, so that's available as well. So we're very excited. Love to see Bokeh available in lots of languages. Certainly, we're heavily invested in Python at Continuum, and so we worked very much on that. So just a quick recap of the present day. So this was about a year ago, just to sort of show you where we're coming from. I was really impressed by these numbers a year ago. I thought that's pretty amazing, all the combined Conda and PyPI downloads. But today, I took this screenshot today, and this is almost 35,000 installs a month. Now I know that those numbers are probably inflated somewhat by continuous integration installs and things like that, but it's still very humbling to see the interest in the adoption that Bokeh's had. So hopefully we'll keep making it better and better. Quick slide just to show the reason we can do that is because we have a great team of people working. Not everyone here is working full-time on Bokeh, but a lot of folks putting in various efforts, working on design, working on client projects, working on the core functionality. A lot of those folks, put in some just amazing work, and so that's the reason we were able to move these things forward. So what do we have today? So I mentioned this callback mechanism, and this is actually pretty cool. We'll see this in the tutorial, so I'm not going to pause to do it now, but this is a reproduction of Hans Rosling's graph from the TED Talk sort of several years ago, where he was showing over time, what was the sort of the trends in sort of this measured, childbirths, fertility rates versus sort of life expectancy for a variety of different countries around the world. And so we can reproduce this in a static Bokeh plot and not too much code. And again, there's no sort of extra server or any kind of program needed. It's just an HTML file with some JavaScript that gets generated for you. So anyway, that's there now. And actually, we want to make this even simpler. We want to take, the lessons we learned, the kind of things people create, so that we can actually encapsulate those into the callbacks that are spellable in Python that don't require any JavaScript. Or someday, the dream would be able to write Pythons or callbacks directly in Python. I think this is a really interesting problem. So if anyone here knows sort of about transpilation from languages to languages and wants to help out, that would be great. I'd love to work on this. I just don't really have time. But if you think it's an interesting problem too, we definitely are always looking for new contributors. Anyway, the user's guide has a lot more information about all of these callbacks. And again, we'll see some examples in the tutorial. Another example that's kind of interesting is the spectrogram example. Showed this off a year ago, but we wanted to show it again at SciPy this year because we wanted to just show that we really sort of added a lot of functionality for being able to embed Bokeh plots however you want, whatever makes sense. And so here's an example of that running. And this is actually, so this demo, just in case you don't know, it's actually reading the mic on my microphone. It's doing a Fourier transform of the data and making that nice waterfall plot. And you get a little power spectrum that gets generated there. And so what's different from the this year versus last year, and sort of why I want to revisit it, is that is that we've made it much, much easier to completely customize the templating and the embedding, right? So you can take a Bokeh plot and put it in your own, web application. If you're serving that from, IIS or Django or Flask or Pyramid or whatever you're using, you can certainly embed Bokeh plots very flexibly in that. The performance enhancements, obviously, too. If you watch the video that I showed it the first time, sort of maybe had some stuttering, and we've made some pretty nice performance enhancements, and we're still working on that, but definitely streaming is a little bit better. But the main difference is that almost all is written in Python now. So the original sort of demonstration I showed off a year ago was maybe 600 lines of coffee scripts. It's kind of cool, but maybe not the sort of thing you'd actually want to have to write. And now it's drastically reduced, and it's mostly in Python. There's still a little bit of JavaScript to help make that work. But we keep pushing towards making that number 0. And that's why I like to show this app, is because it kind of is a proxy for a lot of the things we want to be able to do with Bokeh, and sort of moving it forward moves the broader goals of Bokeh forward as well. Another example here, I can't really show this one off. This is in use by our Memex team, or it's been put together by our Memex team. It has a lot of sort of back-end parts, so it's hard for me to demo live, but I've got a little video that sort of shows it off. And this just shows some capabilities of creating these nice dashboards. So you can have these hover tools that drill down into data. You can have the ability to have these pop-ups. You can have the ability to turn on and off data fields, using the selections and the clicks down there. And so the main thing, though, first off, this is called the FEAT, the Financial Event Analysis Tool, and it's being evaluated by some of the DARPA collaborators we work with. But the main thing that I want to emphasize is that it uses Bokeh 092, or 091 actually when that was written, out of the box, right? There's no sort of special features or vaporware. We didn't have to have a branch or anything like that to do it. That's just straight ahead Bokeh 09, like I said, 1. Actually, by the way, Bokeh 092 was released, I think, this morning. So feel free to do, conda update Bokeh or pip update Bokeh, and you can get that newest version. Another example, just the kind of thing you can do with Bokeh. This example is kind of cool. See if I have it running. So this is actually running. There's a cloud server somewhere, a simple Flash server that has about a 5 gig data cube. And so I can actually, if I select the right tool, like a box zoom, go ahead and select an area here, and then I can get progressive refinement, right? So I can interactively sort of zoom and move through this data cube and have things update. And, sort of showed things like this before as well. But again, what's different, sort of now to today, is that you could actually run it today as opposed to me just showing something off. This is the script that I ran to make that happen. And actually, as you can see, a lot of it's actually this sort of JavaScript callback in the middle. And there's too much of that. And so we're still working on making that even less. But it's still a very small amount of code to be able to sort of interactively move through these sort of HDF or whatever kind of data cube you might have. The Flash server was also very sort of straight ahead to write. Task, I'm going to skip that in the sake of time. A few words, though, about what's coming up, just to close. So people have asked for sort of math techs. We're working on that. I think we've identified some technology that will help us do that. This basically K-Tech or K-Tech, it's the Khan Academy's version of math techs, and so we're looking at integrating that. Also looking at static and headless SVG output. The long-term plan for that is absolutely to use MPL. I think that's probably not going to be ready until maybe next year sometime. And so in the short term, we'll probably have something based maybe on Cairo that can let you get static output. Working on new higher level charts and faceting. Some of the team members, Fabio Pleiser and Nick Roth, are going to be diving into that pretty soon. Also validation, just easier to get error messages. The way Bokeh is architected, this idea of putting these models together and this JSON together, for you to make this graph is really nice, but sometimes it's possible to put things together in the wrong order. And so we have nice validation error messages now that can tell you when something's going wrong. Some other stuff that's coming up. We're looking at some authoring tools. People talk about, how do I make apps? We'll talk about like Shiny and things like that. And so here's this preview of sort of a develop mode. I don't have it running right at the moment, but let's see if this video will play. I guess I don't have. Well, the idea here is that you can actually edit this live document in the editor, and as soon as you save it, the plot gets reloaded. And so it's a really fast iteration cycle. You can just change the colors or change what you want. You can see the output sort of immediately over there, and it's a nice way to iterate based directly on the Python code. And so that's the sort of thing we're going to integrate into this authoring tool that we're currently working on that'll be open source as well. Let's see. Okay. So last thing is we're also working on updating and making the server easier to use and sort of simplifying. We're trying to take some lessons that we've learned from it and make it simpler and smaller. Really, this is what we want to make it, and I know that's a lot of words up there, but the idea is we want to be able to have Python objects and models that we can reflect into the browser, and then that can really be a platform for a lot of things. It'll allow us to shrink the client library, because Bokeh.js has maybe grown a little bit large. We want to split it up. But also let people to do all kinds of interesting and novel things without having to rely on us or without having to put them into the core library. So all of that said, we're also pushing on some of the language bindings in the coming year. WebGL, this I can actually show off. This was merged into Dev 10 just about a week ago. So let me bring that up. Should have this open. So this was clustering with sklearn. It's 4 plots. Each of these, I think, is about 50,000 points. This was Almar Klein's been working on this for us. Whoa. Oh, you know what? I deleted things, of course. Live demos. That's what I get for uninstalling things right underneath myself. Okay, well, we'll come back to that maybe. But we do have WebGL support coming. There we go. So I'm not sure what happened there, but that's 50K points per plot. We can sort of pan and zoom, and it's very fast. And so that's nice. So a lot of more things coming there. We're going to maybe be adding a few other 3D capabilities for some schematic type 3D plots in the near future, but this is just the foundation of that, just enough to get rendering integrated with our current system. So that's sort of where we are. Okay, finally, 1.0. So this year we really want to make sure, a big goal for us this year is to have a 1.0 release. And what that means really to me is to have a lot of stability, right? To have a lot of guarantees about API stability and protocol and interface stability. So that is where we're sort of at, where we're going. I guess I can pause now and take maybe just a few questions, if there's any questions, before we really dive into the notebooks and actually showing off capability and having you guys do a little bit of work yourselves. Any questions first? Yeah.
Is Bokeh.js developed independently of the Python bindings? Like, can you update that without having to
So the question is whether Bokeh.js is developed independently of the Python binding. So they are absolutely separate projects. We do upload Bokeh.js to NPM as its own package. Right now they get released basically in sort of lockstep with version numbers. They don't have to be in principle. It's just easier for us from a development perspective because our team is kind of small. But you can absolutely use Bokeh.js as a JavaScript library unto itself. I will say the actual functional sort of interface and integrations with things like Angular, React are a little bit lacking right now. I'd love to actually help push that forward. I'm just not actually. No, we need some people with some expertise there to come help. So if there are folks that are interested in using Bokeh.js and helping push forward and really define what those kind of interfaces should look like, I'd love to talk to you or have you come interact with us on the mailing list or on the GitHub issues and push it forward. But you can certainly use it today as a library. Okay. Other questions? Everyone ready to do some coding, see some examples? Okay, well let me give everyone a chance to bring up the slides. So just as a reminder, this is on NB Viewer, and you should have a series of notebooks. Let everyone go ahead and download those notebooks. I mean, if you're just going to watch and sort of look at things, you can look at the notebooks on NB Viewer. But I encourage everyone. I encourage everyone to actually go and download the notebooks on NB Viewer. Again here, so you can see tutorial. There's a couple. We're going to start with basic plotting, talk a bit about high-level charts, maybe low-level models, definitely styling. So I encourage everyone to sort of download those notebooks from NB Viewer. Does everyone here know how to start the IPython notebook, by the way? Right. So if you have IPython installed, IPython notebook, you can just, at a terminal, PowerShell, or bash prompt, you can just say IPython space notebook, and that will start a web server. So do that in whatever directory has these notebook files, and you'll get, you should get an interface that looks something like this. Yeah. Sure.
If you want, I can ask them.
Yeah.
How many people want to use IPython and follow the tutorial but don't have it installed? Not that many. Okay, so you're all set.
Okay.
Excellent.
Yeah, but if you want to, there is a notebook service. I just don't know what it is. That's why. If you want to, there's a notebook service. Maybe Cheryl could show us right quick, but that is on Azure that people could use.
Yeah, I could show you very quickly.
There you go.
If you go to studio.azureml.net, click on Get Started, either log in or do guest access. You'll launch into Azure ML Studio. You can skip and one of the things you'll see there is called a notebook. It's a preview service that we just launched. So, so basically you can just pick a notebook, and you'll end up in a hosted Jupyter notebook that has Anaconda underneath of it. And you can use that to follow the tutorial if you want. All right?
Yep, great.
Yeah, let me make sure it's working. Yes, it's working. Excellent.
Great. Let's make sure Bokeh is there. Okay. Let's see what version. Okay. Well, if you do that, though, there may be it's a pretty old version of Bokeh, but we'll see what happens. Worth a try. Yeah. Okay. So if you go to, yes, they're great questions. Let's get everyone set up. So one, you can go to NB Viewer. There's also, that's a great question, though. On GitHub, there is the actual repository. If you go to GitHub Bokeh, there is, under the Bokeh organization, there is this Bokeh Notebooks. So I'll leave that open as well. So github.com/Bokeh/Bokeh-notebooks. And this has all of the notebooks, any of the supporting materials as well. So you can certainly clone that repository to get the notebooks as well. That's another way to get the notebooks. So let me give everyone just a few minutes, make sure that everyone that wants to sort of follow along and actually run exercises has a chance to get set up. And then I'm going to just start going through the notebooks. And I'm going to do some demonstrations. So it's a mix of demonstrations and explanations, as well as some time for you guys to work on things yourself if you'd like to. Yeah, so if you want to actually, work on this yourself and try some of the exercises, then you would want to open up the notebook as a notebook in the Jupyter IPython notebook server you're running on your local machine. Yeah. Yeah, so these are the ones, this is the source code for them. You could clone this repository and that would have the notebooks, or you can download them from NBViewer. It's another way. If you go to NBViewer, so if we go over here to NBViewer rather, and I go to the introduction notebook, all these notebooks have a little download button up at the top, so you can see here, download notebook. So you could download it that way, or you can get them from GitHub. Either way is fine. And then once you have the notebooks downloaded locally, you can run IPython notebook in the directory that those files are in, and then that'll give you the ability to actually execute the code and run things and try things out for yourself. Great. Question? Yes, so this is the first one we're going to look at. If you go to the notebook viewer interface here, it's under tutorials. It's this basic plotting, and it is 01-plotting.ipynb, or if you're on GitHub, if you're on Bokeh notebooks, it's under tutorial here. You can see all the different notebooks here as well. So it's the 01 plotting IPython notebook as well. So you can download that however you like. If you're familiar with Git, you can clone the Git repository. If not, the easiest way is probably just through the NBViewer interface. If you go there, there's this button up at the top where you can download any of the notebooks, and that'll allow you to have the notebook file locally, and you can execute the IPython notebook server to run the code. Okay, why don't I go ahead and get started talking about things a little bit, and then as we break as we pause for the first exercise and give folks a chance to work on things themselves. If people are still having problems and want to run things, then I can come along, or Mike can come around, and we can try to help get things sorted out. Okay. So the first thing I wanted to talk about is one of the interfaces that Bokeh provides. So Bokeh has a very layered approach towards its API. There's a very low-level interface called Bokeh.models, and this is really mirrors the JavaScript library one-to-one. And the idea is you have a model in Python that represents an axis or a guide of some sort, or a glyph, or a plot with all of these different attributes and tools. And so you have all these models that represent these things, and we can turn those into these JavaScript backbone models. And so that's a very one-to-one, low-level sort of interface, and you just have to put things together yourself. And that's very flexible. You can do sort of whatever you want with that interface, but again, it's kind of a burden to have to know how to put all of these things together. And so we have some higher-level interfaces that streamline that process and put things together in sort of natural ways for you. So the first of those is this Bokeh.plotting interface, right? And so I would describe this starting from simple default figures that have sort of default tools, default guides like axes and grids. We can add markers to these glyphs. And by glyphs, I mean visual things like lines or scatter points or patches. And so that's the idea, is we sort of get a basic plot with some basic tools for free, and we can sort of throw data and glyphs at this. And so let's take a look at how we might do that. So the first thing is to do some imports. And if we actually want to go to a live notebook here. So we want to do some imports. So from a Bokeh.io module, I've imported this output notebook function. That's going to allow me to see my Bokeh plots directly in line in the IPython notebook. If you wanted to save to a file, there's also an output file function. There's a show function that will allow us to see it. There's also now, from this Bokeh.plotting interface, there's really the central thing that you have to import is this thing called figure, right? And so let's go ahead and do that. So that gets us the things that we want to use. We run output notebook as well, and we get a nice, you can ignore the warning, get a nice message here that says Bokeh.js was successfully loaded, right? So the actual client library has been loaded in, and so we're ready to start plotting. So how do we actually do that? Fairly straightforward. You can do things with just a little bit of code. Let's take a look at a simple scatter plot first, right? So I want to create a figure. I want to give it a size for the canvas, 400 by 400. You could set that to be whatever you want. And then I want to scatter some circles across. So the one of the simplest ways to do that is just to put the data directly in line here when I call circle, and I can say, I want to plot, these x coordinates versus these y coordinates. I want to give it a size in pixels. I can specify things, obviously, like the line color, the fill colors, the alpha. All of those things can be specified, and so I can execute that. And then at the end, I say I want to show the results, and sure enough, I get out my plot. And because I've used this Bokeh.plotting interface, this plot again has a number of default tools, right? So it has the pan tool already built in. It has, a box zoom tool that's ready to go. It has this reset tool that resets the bounds, or if I actually want to resize the plot, I can even drag and resize the plot. Wheel zoom as well. Preview save, I can save a PNG. So again, we're working on being able to do sort of headless static image generation. Right now, you can at least get PNGs out using this save tool, and so that's available. And yeah, there we go. So this is, that's okay. So let's take a look and see if this matches up with what we expect, right? So it's got, line color is navy, the fill color is orange, the fill alpha there, you can see the grid lines sort of showing through, is definitely less than 1, right? So this allows us to really have a chance to do this. And so we'll see a little bit later that, this is one way to spell things where you put the data directly there, but you can also create these column data sources, as we call them, and reference different columns as the values for x and y. And actually for almost anything, if you want to, for instance, vary the colors for every circle, you can definitely do that, or the line style. All of that is sort of vectorizable over your data. So let's go ahead and actually give everyone a quick chance to take a look. We'll take an exercise is to basically do the same plot, but try it with the radius. So instead of setting size, try setting a radius value and sort of see what happens there. Radius values by default are in sort of data units, right? So size is pixels. Says how many pixels I want the size to be, but radius is a data value measured in data space. And so let's take a few minutes, maybe just 3 or 4 or 5 minutes, and again, I'll take this opportunity to help people that need help getting set up if they want to work along, but otherwise, give you a few minutes to try that out, and then we'll talk about it. Okay, maybe a couple of quick words about this. Actually, I might go ahead and take a step back and also just sort of demonstrate downloading and running the IPython notebook, but let me go ahead and just first sort of show this example. So here, if I change this now to, if I just copy and paste the code and I run with, radius instead of size, well, gosh, it's sort of zoomed out. You can see it's sort of the radius takes these things in data units. So instead of specifying a number of pixels, I might want to pick like a radius of 1.5 or something, and they get smaller, maybe 0.15, obviously. So it just depends. So, but if you need to scale the size of these circles by the data, you can certainly do that and have them scale in data space. So the way that these behave is obviously, if I zoom in here, these circles get bigger because they're specified in data units, right? I said I want the radius to be, from 0.15 across, and so that actually is preserved as I zoom in. But these are specified in pixel units, so they don't get bigger or smaller as I zoom in. So that's sort of just a distinction between pixels, screen space units, and data units. So I just wanted to draw that out. What about other markers besides circles? Obviously, it's possible to do that as well. So it's very simple. In this case, there's a .square method on figure. So I can say p.square instead of p.circle. But here, another thing that's different is instead of giving it a single size, I've given it now this vector of sizes, right? And so now every single one of these glyphs that gets scattered has its own size, right? So these sizes, again, are in pixel sort of screen units. But you can see there's the small one, and then they get a little bit bigger all the way through. So it's possible to vectorize pretty much any one of the visual properties of these glyphs. You can always sort of either give it a fixed value or you can attach it to data. And we'll see how to do some of that later.
Use the data value itself instead of using arbitrary values for size. Say a data value times something.
Yeah, absolutely. So that's really what radius is. So radius is in data units, right?
No, for individual, for example, if I want to show circles, right, the size of the circle is based on the value of the data.
Mm-hmm. Yes. And you want it to grow or shrink as you zoom in or out. Yeah, so that's what radius is. So, radius obviously is so size sort of measures the overall diameter, and radius is different, but they do have these different units, right? By default, radius is in data units, and so you could actually do, it's a little bit complicated, but you could do, I think this would work, size units. I don't use this much, so let's try it. Okay, we may have gotten rid of that. Yeah, we can't do so. So size units are always in pixel units. It used to be possible to do that, but the radius though, you can definitely give it, your data, and it'll scale proportional to the data size, right? And so in this case, I gave it a single radius, but I could certainly give it this list of values for the radius, right? Let's go ahead and do that. And let's maybe make it smaller because those will be really big. So 0.10 through 0.30. And so they're all scaled, but now as I zoom, the circles get bigger because the radius is specified in data units, right? Does that answer the question?
Yep.
Okay, great. Okay, so there are a lot of markers that are built into Bokeh, standard sort of things you would expect, right? Asterisks and circles with X's through them, or squares and triangles and all of these things. So all of those are sort of built into Bokeh. So quick exercise let folks do is to just plot some different markers, right? So try adapting the code that's above and plotting some different markers. In the meantime, I'm going to show quickly just this workflow of maybe getting the IPython notebook started, because I think there are some folks here who may not have seen that. So yeah, so just people can start working, or if you want to pay attention to me, I'll keep talking about the IPython notebook download. So to download that, I want to go to this Bokeh. I start out at NB Viewer. I can see all my tutorial notebooks. I can go on to basic plotting. So again, NB Viewer is a static presentation of IPython notebook. So you can't actually run code here. This isn't like the Azure notebook server that Shirok was mentioning, or like Bakari or anything like that. You can't run any code. This is sort of a static snapshot of a notebook. But we can still download them locally and run them locally. And so that's what this button here is. So I'm going to say, click on that, and I'm going to say save link as, and I'm going to save it in my home directory, or my desktop rather, as this 01 plotting. And so now if I go to a terminal, and I go to the directory where those notebooks are, and I type IPython space notebook. And so you can do that in PowerShell or in Bash shell or whatever is appropriate. That brings up this server, and I can see, oh, there's the notebook I downloaded. So sorry, I should have gone over that first. That's probably a good thing to do at the start of the tutorial, so I'll do that next time. But here you can see that. And now if I click on this notebook here, this isn't a static presentation or static image. I can actually run and execute the cells. And I do that by hitting the Shift-Enter key. So I can execute this import by saying Shift-Enter. I can execute this cell by saying Shift-Enter. And then I hit Shift-Enter on this cell. And so that actually executes and runs this Python code in the notebook server. And I can see the output directly in line in the notebook. So hopefully sorry, I apologize for not maybe showing that more explicitly in the beginning. That's a good thing to do, and I will do that in the future. So. Question? If it's not working for you, I'd love to see it, and let's make an issue. It's definitely has always, like here, if I go to the resize button, I definitely can resize this plot. So if you're having an issue, I would love to take a look at it maybe a little bit later on, and we can maybe file a GitHub issue and see what's different about your configuration or what might be broken. Okay. Question? Mm-hmm.
It doesn't scale if you're scaling one axis versus the other. Can you switch those axes to scale bits?
So that's a good question. It's interesting. There's occasionally some subtleties actually around that, especially with some of the markers like circle, where there's actually ostensibly a radial symmetry, right? But if you don't have a one-to-one aspect ratio, sometimes people get results that are at least unexpected to them. Mathematically speaking, if you have non-one-to-one aspect ratio, and you're plotting circles, you probably ought to try to squish them or something, but a lot of times people don't want that. And so you can definitely there's not really any way to have, I think, mixed units if what you're asking for. We sort of tried that before. Although with some of the other glyphs that we're going to see, like rectangles, you can, for instance, have like a height in screen units and a width in data units. And so we'll see some examples of that. But for the markers, the oval should, I believe. We can check it when we get to that a little bit later. Well, oval is a couple of Bezier curves, Joan. It's not an ellipse. We probably ought to add an actual ellipse, but yeah. So oval, though, you have to specify the major and the minor axes separately, and so for that reason, you can say, oh, I want you to measure in this dimension. I want you to measure in screen dimensions. In this dimension, I want you to measure in data dimensions. Circles, though, don't have that. Even though they actually do have this extent in 2 dimensions, you only give it one parameter, and that does complicate things a little bit if you don't have a one-to-one aspect ratio. So, but that's an interesting question. We can talk about that sort of more. Come find me. We'll talk about it, and I'll show some examples. It'll be good. Okay. So let's see. So the next exercise here was just to show some different kinds of markers here. So again, I can just copy the code up here and sort of substitute in different ones, and we can see the results. It's fairly straightforward. Here instead of squares, I want to add triangle. And sure enough, I get triangles. Hopefully no surprise there. Or I can add, x, sorry, it's a lowercase x. Gives me little x markers around. So, it's fairly straightforward. I mean, it's, you need to be able to plot simple things and simple scatters, and Bokeh can let you do that. Okay, so scatters are great. What about lines? We want to be able to plot, obviously, data that has maybe some connected, component to it. Maybe it's a time series we want to show or whatever. We want to have these sort of continuous lines. We can do that very easily. In the Bokeh plotting interface, there's a line method on figure, p.line. It's very similar. It takes the same kind of arguments. You can give it the data. As we'll see later, you can also give it a reference to data in one of these column data sources. But here you can specify things like the line width or the line alpha or whatever you want, and you can get that line. And again, because it's Bokeh plotting, it just comes with all the tools sort of built in and this basic sort of standard functionality. Another example here, let's take a look at images. It's definitely possible to show images. This one's a little bit more sophisticated. I'm actually using NumPy here to create the color data. There's a couple of different ways to show images in Bokeh. One is that you can create an array of data, like maybe you have temperature values or pressure values or whatever, and you can send the data, and then you can tell Bokeh to color map it on the client with some particular color map. But you can also send actual just raw RGBA data. And so that's what's going on here is I'm actually using NumPy to create this RGBA data. And then I'm calling my image RGBA renderer, just like I did with circle or triangle or line. And sure enough, that's going to give me a plot that has this data. So I just did a little simple diagonal sort of gradient across and varied the color, varied the RGB values. But you can see again, it just lets us show it up. So whether you have raw RGBA data, like maybe you have data coming off if you're a scientist, you might have data coming off some sensor or a camera, CCD or something like that, or maybe you have arrays of data that are actual values. Either way, whether it's raw RGBA data or values that you want to color map on the client, Bokeh can do both of those. A lot of other kind of glyphs. Not going to go into sort of deep dive about this because there's a lot of material we want to cover, but I'll at least mention what's available and maybe click on the links and show you in the user's guide what's there. Obviously, rectangles and ovals, things like that. These things have a width and a height. These have an extent. They're not scatter markers, but they are positioned by their centers. Segments and rays, all kinds of wedges and arcs and annular wedges, things like that, as well as specialized curves. If you want to be able to draw things like Bezier, quadratic or cubic curves, you can do that as well. But for instance, if I go to rectangles and ovals here, and we look at some of those, just a fairly straightforward stuff. Again, we can vary the parameters of these. Either we can pass fixed values, or we can, pass connected to the data. In this case, there's quads is what this one is. So quad is an axis-aligned bounding box. Rectangles, you can also specify an angle for, so those can be rotated. So here in this case, we've actually rotated those angles, and of course the angle can be vectorized over data as well. And ovals are very similar. Again, they take sort of a width and a height, center position and an angle, and you can sort of move those around. All of these, by the way, are in the, so this is the user's guide. All of these are in this user's guide for Bokeh plotting. All of the glyphs have live plots with examples, so you can go play around with them and sort of see exactly what the code looked like to get you started very quickly and very easily. Okay, go back here. Okay, so that's great. We can draw some circles on a plot or whatever. What if we want to draw multiple things on a single plot, right? I mean, that's a pretty common thing you probably want to be able to do. So that's fairly straightforward in Bokeh. You just simply keep calling more glyph functions, right? So I can call p.line and p.circle on the same figure, and sure enough, if we look at the results, well, that's great. We get a line that has these nice markers on it. So higher level interfaces might do this automatically for us. So this Bokeh plotting interface is kind of in the middle. It's kind of a layer, a level of verbosity similar to MATLAB, if you're familiar with that, or Matplotlib. And so it sort of lets you specify what these visual shapes should look like without imbuing a lot of semantic meaning or sort of data transformation. So we're working on a Bokeh charts layer that's even higher level that sort of takes care of some of those things. But anyway, this is basic plotting. So let's give everyone a few moments to maybe do this exercise or maybe the last exercise. So the last exercise was just to try to use some of the different glyphs like rectangle or oval yourself. And then this last next exercise here is simply to combine a few glyphs together on your own plot. So we'll give everyone 4 or 5 minutes. And again, if you have questions, I can come take a look or can wave mic over, and then we'll be done with this section. We'll move on to the next chapter, Bokeh charts. The next section I want to go through, just run through very quickly, is this Bokeh charts high-level charting interface notebook. So I'm just going to run through this as examples and talk about it a little bit. We won't stop to pause in the exercises because I want to get to the styling and adding interactions notebooks and maybe the embedding one as well. But the idea, again, is that you have sort of very layered levels of interfaces. So Bokeh.charts, maybe does some work for you, right? The idea is that you can have sort of one-liners to create all kinds of different common charts, and maybe those charts even involve doing some kind of statistical aggregation or, in the case of a histogram or a box plot. And so that's sort of all wrapped up in the chart definition. And so again, here I'm using NumPy and Pandas. Pandas, if you don't know, is a really fantastic library that's really helped spur the adoption of Python for data science. It's a sort of a tabular sort of Excel in a library, kind of that kind of notion of like a labeled columns, but being able to manipulate them programmatically. That's what Pandas is all about. It's been really useful in a lot of contexts. We do output notebook again to load Bokeh into the notebook, and the first chart here is a simple scatter chart. And you notice, I gave it my values, and there's a variety of ways that I can give it the values, and basically it's going to auto color, right? So it sort of auto breaks down the groups and colors those for us. Again, we have sort of a default set of tools here. In this case, we also have this nice crosshair tool. I should mention that we're currently working on, this is the newest and sort of most recent interface, and we're still evaluating and evolving this interface a little bit. So I did want to mention that. The Bokeh.plotting interface is very stable. Bokeh.models is basically completely stable, but there will be some upcoming changes to Bokeh.charts to make it a little bit easier to use with things like data frames. Here's another example with stacked bars. So again, a lot of different ways to specify sort of this metals data. Here I put it in a data frame with bronze, silver, and gold columns, and I can get a nice stacked bars out of that as well. Finally, here's a histogram. You can actually get populations, different histograms, right? So I create two different populations here. There's a normal distribution as well as a log normal distribution in my Pandas data frame. And then I can call the histogram plot. And so I can actually get, I can tell it the number of bins that I want. It actually does uses NumPy to create that or to calculate that histogram and overlay those two populations on one another and give you a nice legend there as well. So the idea behind charts is really to be able to generate high-level charts very quickly, and then the further work that we're sort of about to embark on is to be able to combine different charts, but also to have things like auto-faceting thrown into that as well. So instead of just necessarily stacking or grouping, you might say, I want to facet by this other variable and then group or stack by a different one. So that's, this is what's there now. It's evolving a little bit. There's going to be quite a few exciting things, I think, in the next few months coming into Bokeh.charts. So I just wanted to have at least a quick chance to show that off. Oh, yeah, good question. So I mentioned in the initial slides that we had added some validation code. We haven't actually turned on the throwing exceptions if there's errors. But this has actually been very instructive for us. We've seen that in some cases we're actually doing some things we shouldn't do. So one of the sort of assumptions about these column data source structures that I haven't talked a lot about yet, but that sort of underlie all the plots is that they're a collection of columns that all sort of have the same length. They're sort of a cheap Pandas data frame, if you will. And in this case, we've apparently constructed one that has columns that aren't all the same length, and we shouldn't be doing that. So it doesn't, in this case, cause the plot from rendering. And it's again, we haven't turned off sort of the strict checking, so that would actually raise an exception. But in the near future, probably in Bokeh 0.10, these kind of validation errors, that we check right before we actually generate the JSON and try to display the plot. If there's a validation error, it'll actually raise an exception. We haven't turned that on just yet. Yep. Question.
Are you guys working on adding tooltip support to some of these charts?
We have tooltip support. We have quite a lot of tooltip support. Let me go. First of all, I should mention anyway, bokeh.pydata.org. If you go there as well, this is the main doc site. Has that user's guide. It has a quick start. There's also this reference guide I mentioned, but there's also a gallery. There's lots of different ways to learn. People learn in different ways. One of the best ways that I learn is to just go say, hey, what looks like what I want. I'm going to go look at that code and try to bang it into shape until it does exactly what I want. But if you go to some of these examples, for instance, this is a reproduction of a New York Times chart about U.S. unemployment. This has a tooltip hovering over it, right? And so you can see there's a hover tool here, and it's very easy to spell. The hover tool here, you just say I want the label to be date and rate, and I want to show, here's the date and the rate columns are what I want to show up. So that's one example with the hover tip, and we'll actually get some more of this later. But here's another example with this periodic table chart where we show sort of a lot more information in the hover tooltip. So that's in this adding interactions notebook that's coming up in just a bit. So, but thank you for asking. If the question was about, I think that's what you're asking about. Yeah, great.
I think it's a question also, can you bind that to a matplotlib plot?
What do you mean by bind it to a matplot?
Can you add the tooltip to Pandas plot?
So, I mean, the short answer is no. So Bokeh doesn't use matplotlib to implement anything, right? So, We do have an NPL to Bokeh, and it offers some limited support for converting matplotlib to Bokeh, and so depending on the plot you're trying to show, it may work. Yes, we use a library called NPL Exporter, which is quite nice, but it doesn't necessarily cover the full range of what matplotlib does. There's currently in the works. The matplotlib team is working on a new feature to be able to have basically a JSON export, save and load capability. And once they've got that, we can make basically any kind of interoperability happen. But that's a little ways off. But right now, you can get some basic interoperability with NPL.2Bokeh. And I can't guarantee that it'll work in every circumstance because there's some NPL plots that are just sort of too sophisticated for us to handle through that interface. But more will be available later. Cool. Cool. Good questions. OK, well, let's get back to. Let's go through this styling document. So this is 04. If you're looking on the IPython notebook NB viewer site, we did basic plotting. I sort of went over very quickly high-level charts. I'm going to skip low-level models. I don't think that we don't want to take too much time to do that, but I encourage everyone to look at it. If you actually just run it, I'll show you what's in it. The low-level models interface definitely gives you the most flexibility, but again, it's sort of, the responsibility is sort of upon you to put everything together in the right way. You can think of it sort of as a bunch of sort of, building blocks, and, how do we actually sort of put those together? And so I'll run all. Why is it not showing? I'm not sure what's going on there. Let me restart this and clear all output. There we go. So this is another reproduction. One of our developers just recently did. I'm not sure what that hookup was, but this is sort of reproduction of sort of showing Usain Bolt's sort of Olympic, compared to other Olympic sprinters, and sort of how far behind other people were, and sort of what year they ran. And so it's just this example of having sort of a lot of flexibility to sort of place things in different locations and have a lot of control over the style. Like here's this little extra annotation and that sort of thing. So you can definitely put this stuff together with the low-level models, but I think right now maybe this styling is a little bit more appropriate and useful for this interface. So let's take a look. So again, I'm going to import, from the notebook, and just to mention, a lot of this information is in the user's guide, right? So we can see a list of all the different properties that we can sell, we can set. There's all the different plots here that we can, the attributes that we can set on plots. And so if we click on these, and we look in the user's guide, we can see here's all the different visual properties, things like, the fill properties, line properties, text properties, right? All things you might normally imagine. And then we can set plot properties as well. Things like here, what's the dimensions of the plot, the title, obviously, the background. So all this stuff is here with live plots. You can sort of see examples of how to set those. So let's go through a few here. Actually, maybe let's take a look at. Yeah, I will just go ahead and copy this one. So I just copied one from down below. It's a simple little plot, but I can say things like, oh, I want my plot height or plot width rather to be 600 instead, and I can get a bigger plot. I can set things like the title, equals my title, and get that to show up. So that's sort of the plot property. So let's take a few minutes and let you guys just sort of look at the different plot properties. Again, I encourage you to follow the link here for properties, but also to this plots link under styling visual attributes. And that shows, I can set the different border shapes around the plot, the different sort of outlines around it. So you guys can sort of play around with the visual appearance of, one of the plots you created in the last exercise, or a new one that you want to create. And I'll give you just a couple of minutes to take a look at that, and then we'll move on. If you have questions, we'll come take a look. So as I go through this, I'll mention that there is another way to set things, right? So here I've sort of passed arguments to figure here, but it's also possible to say things like, to set these as attributes. And actually,
Just a quick heads up.
Yep.
The version of GitHub is slightly different than yours in terms of what things like it doesn't have the properties links like you have.
Oh, yeah, sorry. I will update that later. Sorry, I did make those changes today, so I need to push those still. I will make changes, and they'll be in there. So if you just go to the user's guide and you go to styling visual attributes, that's going to be where that's found. And this actually just reminded me, the question at the back of the class from someone was about IntelliSense and does it complete, and I was sort of blanking. I'd forgotten that it's not actually the function arguments where you can get that sort of completion, but if you start something like this where you say p dot whatever, you can get a list now of all the attributes. So here, like outline line dash, outline line alpha, I can set all of these things, so there's all these different outline properties I can set. So if I want to set outline line, dash equals to, 3,3, then I can get this nice weird dashed outline if that's what I wanted. But there's all kinds of things here. I can set the, if I just hit p dot, I'll get a list of a bunch of stuff, but you can see things like the functions for the glyph functions, but also things like min border and the outline properties and things like the title and all of those things. So sorry, I had a little bit of a brain freeze there, but. Yeah, so that's a little bit harder. That's a good suggestion. I don't think we're quite there. I won't say that it's impossible, but you'd have to get a hold. You'd have to make the circle glyph and then get a hold of it. And so what we have now is sort of tab completion for dot properties. And so if you have a hold of one of these circle glyphs, you could do that. But getting a hold of that, I'm going to say, is a little bit of maybe a task right now. So that's a good suggestion. I think we should figure out how to make that happen. I'm not sure if IPython Notebook offers that kind of integration, but we could also look at other IDEs as well that might support that kind of IntelliSense. And if there's anything we can do to make those kind of integrations happen, I would certainly like to. Yep.
Shift tab.
Shift tab? Oh.
Shift tab in the shift tab.
Oh, so that brings up the doc string, which is definitely useful here, but I don't know that that's going to get us everything because we have a lot of sort of magic. The Bokeh system uses some fairly sophisticated means to be able to auto-serialize these models into JSON, and so in some cases it sort of short circuits some of the standard Python, not short circuits, but helps automate, I should say, some of that machinery, and so we just need to help it along to provide more help. So cool. Okay. So that's an example of making a plot. Let's take a look at axes. Obviously, probably you want to manipulate and change the visual appearances of things like axes and grids. So let's take a look at how you might do that as well. So the plot itself, the figure here, has this attribute like x-axis or y-axis or dot axis. And these actually return lists because you might have more than one x-axis. It's actually possible to have like twin axis plots where you have different axes on different scales. So you actually get back a list. But this list is actually a little bit special. You can set attributes on it, and it will set the attribute on all the value, all the objects in that list, right? So here, in this case, I just have one axis, and if I set, p.xaxis.axis label to temperature, that's going to have the effect that I want. And so it's just a nice sort of convenience. And so we can take a look at some of those here. So a lot of different things you can set about the axis, right? So you can set the actual line properties of the line itself. You can set the text properties of the label and also how far it sort of stands off from the axis. You can set the major labels or what labels the ticks, the major ticks. You can set the line or the text properties of that as well as what the angle of the orientation it's at. The major ticks and the minor ticks you can set all kinds of properties about what do those look like as well. And so here's kind of an example of showing some of those here where I've done pi over 4, but I could do pi over 6. And rotate those labels, right? And so now those are labeled. Or I can do something like, p dot x-axis dot minor tick in. This is how many pixels it sort of extends into the plot. I can set it to be -1, or 2. Oh, 2. And so it just changes the visual appearance. It's probably kind of hard to see on that scale, but I'm changing the how far do the ticks extend inside the plot. So you can have really fine-grained control over lots of the visual properties. You don't always have to. We try to pick sensible defaults, and again, we're working to make a visual design pass to make things look even better by default. And we're also looking at adding sort of templating and being able to have lots of different template styles that are easily selectable and choosable between, but at the lowest level, you can always get down to all of these, sort of knobs and dials and really customize the visual appearance of these plots. Okay, this one example shows sort of a lot of things here changed. I've changed the color of one of the axes, and I've changed the color of the tick labels and their orientation, and let's scroll up to the code. Yeah, so here, I've given labels to the axes, I've changed their standoffs, all kinds of things. So again, you have lots of control over the visual aspect. So maybe take a few minutes, and if you guys, everyone here just wants to, show a plot, and maybe play around with some of these properties. Again, you can start by just sort of copying and pasting and seeing how things go, and modifying things to try to see how they look. But if you all want to do that, we'll take maybe just 3 or 4 minutes, and then we'll finish up. Which one is? Remind me what all that does.
Just get rid of all of the axes, all of the line on the chart.
Oh, no, there's not. But that's a great idea. So those kind of suggestions are great to get from from users. So I'd love to get that as like a feature request on the GitHub. We definitely want to be able to have the ability to define user-defined styles, but also to have a multiple sets of sort of common styles that we can switch between, and so sort of a despine style. Exactly, themes, exactly, right. So, yeah, so in fact, that'd be great, like having a Seaborn theme. And so that's I think, a thing we'll have probably in the near future. But yeah, question in the back.
Can you toggle or turn on and off the zoom with an axis, whether or not it does zoom when you...
Oh, yeah, well, so I think I will have to look into that. Emma, you mean this specifically, the one-dimensional zoom here?
Even if you're just in the grid and the plot itself, doing that in either zoom only Y or only X, you can toggle the X and Y on.
Oh, you want that. You want to be able to say, I want it. Yes, you can. Yes, so you can turn off on the zoom tool, there's a field that says, I want it to only zoom in this dimension or only zoom in that dimension. Yeah.
Oh, it's in, okay.
Yeah, so we haven't talked too much about how to add tools. There's adding interactions, we'll talk a little bit more about that, but you can actually add the tool object yourself and configure it the way you want, or you can pull out the tool object and configure it the way you want. But that's a configuration on the tool.
Can you set a maximum and minimum range on axis?
No, but you will be able to soon. This is an old, long-standing issue that probably should have been implemented a while ago, and it's been asked for a few times in the last week. So I think I'm just going to go ahead and I'm going to do it like this weekend sometime, or do my best to. So it shouldn't be hard to implement. So we'll just need to do it. So, yeah, great, good question. The question was whether or not you can have a maximum or minimum bounds on the range, and the answer is hopefully very soon. Yeah. Question. Yeah. Oh, sorry, I didn't realize there were 2 questions. Sorry. Yes. Here you go. Oh, so if you use output file, one quick way is to use output file instead of output show. That'll just generate basically a plot with nothing else inside of a HTML file, and then it'll open up a browser when you type show or when you execute show. The other notebook that we're going to see in a bit, the embedding one, actually shows a variety of ways. Like if you want to embed a chart in your own custom HTML or serve it up from a Flash server, that's what that embedding, I think we're going to have time to get to that one, but that's what that shows as well. But if you just do output file and then do show, it will save it to an HTML file, a fairly standard one, and then just open up a browser. Yeah. Right. I think you had a question as well? Yeah.
Log scales.
So if you go to the user's guide, the question was about log scales. The first question was about showing to a browser tab instead of in the notebook, which you can use output file for. And then the next question was about log scales for the Bokeh.plotting interface. If you go down to specifying axis types, you can see here there's ways to specify categorical axes, date time axes, right, that zoom in and out to nice, nice sort of numbers when you zoom in and out. But also log scale axes here as well. So here's an example that shows a log scale. So this is an example where having sort of that math tech capability would be really nice. It'd be nice to have much nicer annotations here that showed the exponents as exponents. We're not quite there yet, so sort of has this hokey, carrot for the exponent. But like I said, I think we've identified the technology in a way forward, so we can hopefully integrate that Kotech package to get sort of math text annotations very soon, and then you can have much nicer labels for tick labels. Yep. Other questions? Yeah, one more question.
That was in the beginning, you showed like product animations.
Yeah. Well, sure. Let's. This is a pretty basic tutorial. I'm probably not going to get to a lot of that. Maybe a little bit in the adding interactions section in just a bit. But definitely come talk to me. I'm going to be here all weekend and also for the sprint on Monday. So I'm always happy to answer anyone's questions, and we can sit down and even try to bang out some code here and there. So just come find me. But let's wait for the adding interactions section to see what we get to today in the tutorial. Okay. Moving along, because we're running long. So also another thing we can configure is grids, of course. Let's just see some examples maybe, and we won't maybe pause for an exercise, but we'll just talk about it. So here again, so just like x-axis and y-axis, and axis, I have an x grid, y grid, and grid sort of convenience functions on figures that gives me back all of the the x grids or all the y grids, and so I can set properties on those like, hey, I want to set the alpha for the y grid to this, and I want to set the line dashing for the y grid for that, and I want to turn off the x grid completely, and so now you can have this nice plot that only has the the horizontal rules for the grids. Another thing we can do is filled bands, right? So that's pretty easy. There's a grid band fill color option that you can give it. Here I said navy, and I gave it an alpha, and so I have a nice, so these nice filled bands in between. So all of those are, again, just analogous to that axis. These actually return lists. So if I look at p.xgrid, I actually get this thing that looks a lot like a list. It's actually a subclass of list that lets me set attributes sort of on all the items at one time. And so that's what xgrid is going to give you. Okay. Last section here on styling. It's also possible to style legends somewhat as well, just like with xgrid, ygrid, x-axis, y-axis, all of those. There's a p.legend. This is an attribute of figures. Basically gives you back my legend object, and so I can set things like the orientation. I want it to be the bottom left, and right now it's pretty basic. We're going to add some more functionality to being able to position the legend. Right now you can basically give it one of the corners or a standoff, but we're going to make that a bit more sophisticated as well. But right now, you basically in each of these glyph functions you say where is it? Legend equals 3 times sine x, and for every one that you do that, it collects those together and draws the legend for all those things together. So you can see here that 3 times sine x is the green squares with the line, and 2 sine x is the dotted orange line, and just sine of x is the blue solid squares with a line, and that's because I've passed in legend as the argument to all the glyph functions. And it basically just collects up all the legends that are the same and draws those glyphs together. Okay, let's go ahead and move on to sharing, right? So this actually is going to answer some of the questions that are over here about ways to share bokeh plots. So let's take a look at that. Okay. So here, I'm again going to use Pandas. So I'm actually reading from the Yahoo Finance API, is iChart.yahoo or something like that. And so it's you can just read in this financial data, and so I can read that into a Pandas data frame. And so here I have a Pandas data frame for Apple, Microsoft, and IBM, and all of those things. And so here I can plot lines for that. And so this function, this is actually a function now. I haven't shown my plot, but this is actually this make figure function. I tell it things like I want a date time, and I want to show the date versus the adjusted closing price. I can set the colors, and I can set things like all the things we styled in the last section. I can set all of those things there, and that gives me this nice plot. And so in the notebook, as we've seen, we do our imports. We run output notebook to load the notebook, Bokeh.js in the notebook, and then I can just get my plot and call show. And did I call output file there? Somewhere I must have run output file. Interesting. Not sure where I did. Let me actually restart this kernel. Clear all the output. That was weird. Okay. So yeah, so pull in the data. Takes a second to actually read that down. Output notebook. And there we go. So I must have, I think I must have written output file somewhere. We'll see output file in just a second. So here we go. So yeah, so here's my plot. I've got my nice date time axis that scales. Another thing you can see here, this is something you can turn off, but one of the things that we have that can help preserve interactive response rates when you have a lot of data points and you're using the canvas is something called level of detail downsampling. And so this is, you can turn this off, you can customize it, but by default, if there's a certain number of points, it actually just starts decimating the data during interactive motions like pans and drags, so you can maintain these nice high interactive rates for panning and zooming. Actually, with the WebGL capability we added, this may become less important. But certainly, if you want to use or need to use just the standard canvas backend, then that LOD downsampling can be helpful. And that's also described in the user's guide as well. Okay, so the next thing we can do is we can say output file. And so now I say output file tutorial sharing.html. And now if I call show, this is what it does. It opens up this file, just a very basic HTML file. It just has the plot in it and nothing else. So no sort of extra styling or formatting, but it's the same plot. It's got the same tools. I can resize it. I can pan, and my pan tool, I can pan it up. pan it around, and I can use my wheel zoom. And this is the way this is created. This is a static HTML file with the data embedded in it. I can actually just email this to someone. There's no extra server or anything required. It's just a static document, even though it has these interactive tools in it. And we'll see in just a bit in the next section that you can actually have a lot of rich interactivity in these static documents. Okay. So, yeah. So yeah, so that's that point that I mentioned where the static output is something we're working on. That's actually a surprisingly thorny technical issue. And right now you can use with user interaction, you can hit this save tool, and you can get a PNG, but that requires user interaction. So to be able to do it like headlessly without user interaction is something we're still working on. That is, I would say, a current fairly high priority for us. Can't give you a firm estimate, but it certainly would be in a 1.0 release, hopefully later this year. There's a few approaches we're going to have to try to making that happen. So, yeah. Question?
Why would the charts not showing up before?
I'm not sure. So the notebook, it should never be a problem outside of the notebook. Occasionally, the notebook with its out-of-order execution and also the publication of JavaScript and mechanism is a little bit complicated. Occasionally, it can get a hiccup, and I just typically restart the notebook and clear the output. But obviously, if there's a way we can reproduce some problem, I'd love to find a way to fix it. It's just sometimes it's hard to reproduce these little hiccups in the notebook. But most of that's just because Bokeh is a fairly complicated and large library, and so sometimes there's a little bit of interaction with the notebook that's a little weird. We actually used to have a very sort of more MATLAB style interface that was implicit. There was sort of an implicit figure, and you would just say circle or square. And what we found is that sort of having that with the possibility of executing things out of order in the notebook really just became impossible to sort of reason about things. And so that's why now we have like a p.circle, a plot.circle or plot.line, and it's a little bit more explicit. But there's still cases where it's occasionally strange. Anyway. Okay, next thing, show how we can template Bokeh plot into your own sort of custom document, right? So here, this is a Jinja 2 template. So Jinja 2 is just a templating language. It's very commonly used in sort of Python web app dev. Here you can see that I've referenced, from the CDN, the Bokeh, in this case 090 release, but I've got a title there, and here's a paragraph, and then I put in this script and div, and that's where actually the plot and the script are going to go. So here's my template. So I can define this Jinja 2 template. And then there's this bokeh.embed.components function. And so if I pass my plot to that components function, what that's going to give me back is a script and a div. And so those are exactly the things that I need to substitute into my plot. And wherever the div goes, that's going to be replaced with the plot, right? Is basically how it works, very simple. So here I can, for instance, call the HTML. This is IPython publication method HTML, and I can just render the template, and sure enough, it shows up there. But now it has this extra formatting, right? It has, hello Bokeh, and below is a simple plot. So you could imagine serving this up on a web server, that template. So you can embed Bokeh plots in your own documents very easily. I think there was actually recently a pull request from a new outside contributor who added the ability to also specify your own custom template to not output file, but bokeh.save. So you can also do this sort of in a more simple way. But yeah, so if you can imagine if you have lots of CSS and want to be able to sort of control the way things look, this is hopefully a nice way to do that. Just finally, as an example, we can actually use Flask right here to do that, right? So here, very simple Flask server. The way Flask works is you define a function, and you have it return some HTML, and then you add this little decorator that says whenever someone hits the route or whatever endpoint you want to define, call this function to get the result. And so if I run this, if I make a Flask app and I say app.route, and I give a function that simply returns my plot rendered from that template, I can go here, and let's uncomment this. I say app.run, and so let's actually go to localhost port 5050. And we see that there's been served up by our Flask server, right? So very easy, lots of different ways to embed Bokeh plots into, say, Flask or Django or IIS or whatever web framework you're using. It's super simple. Bokeh.components is a really great way to do that. There's also something called auto-load static if you want to be able to save the data sort of in a sidecar.js file or the script. You can use auto-load static. Auto-load server if you're using the Bokeh server. We're not going to talk a lot about the server today. Just to mention that, again, we're sort of working on making the server better and simpler and easier for people to deploy. But that's there as well. So lots of different ways to embed Bokeh visualizations in your plots. Okay. Great. Too many tabs. There we go. Stop the kernel. Okay. So questions about this section for sharing and embedding. Actually, I do want to show one quick thing. Is, Bokeh also has its own sort of notion of like a widget set. And so when I talk about embedding, I don't just mean plots. I could mean multiple plots, but I could also mean, like here's a couple of plots arrayed in different ways. But I can also embed different kinds of widgets like buttons and button groups and things like that as well. So those are also possible to embed and define events that happen when they get interacted with, of course. Okay. Speaking of which, let's talk about adding interactions, right? So the first thing to talk about for adding interactions is, how do we get some simple layouts? So we're going to be, we have some simple stuff built into Bokeh, things like a notion of like a grid plot or an HBox or a VBox. But of course, you can always embed individual plots, into your own layout or your own templates, however you want, right? So if you don't want them in our simple layout, you can just embed them in your own custom templates. But for the purposes of this tutorial, I'm just going to show, for instance, this grid plot. So here I've arranged 3 plots in a row, and you can see, they all sort of have the same set of tools defined, and that's really great. And the reason that it's nice to show that is what I actually want to get to, some of the cooler stuff, is it's possible to have linked interactions like linked interaction or linked panning and linked brushing very simply in Bokeh. So when I say linked panning, what I mean is if I pan or zoom one of the plots, if I change the range of one of the plots, that some other plot should be able to respond automatically and do the same thing. And when I say linked brushing, what I mean is that if I make a selection on one plot, that really I should be able to get the same selection, highlight the same corresponding points on a different point. So here's an example of using linked panning. So to get linked panning in Bokeh, it's very simple. All you do is you share a range object between 2 plots. So here I've created 3 different plots, S1, S2, S3. So I've got 3 calls to figure. The first one I'm drawing circles on, and the next one I'm drawing triangles and then squares. But what I've done is I've pulled off this thing called S1.yRange and S1.xRange, and I've passed those as parameters to the other plots. So I've shared both the X and Y range for the second plot, and I've shared only the X range on the third plot. So what that means is that if I pan any of these plots, the other ones respond in kind. And so because the second plot shares both ranges, they're linked in both dimensions, but because that third plot only shares the X range, it only moves correspondingly in the X dimension, right? So it's very easy. Sharing ranges is how you get linked panning in Bokeh. So that's the easy, succinct way of expressing that. So let's go ahead and take actually, let me show you the next section, then we'll take a break for an exercise. So linked brushing is also typically easy to express in the case where you have the same kind of data source shared between 2 plots. So here I want to introduce something we haven't sort of seen before. I've mentioned it, this column data source. And the column data source is really kind of like a pandas data frame. It's just a bunch of named columns. So there's, the name of the column is X and Y0 and Y1, and it just has an array or a NumPy array or a list of data for each of those names. And so here I've created literally a Python list in this case, but they could be NumPy arrays or whatever you want. And here I create these values Y0 and Y1 with some list comprehensions. And I put those in a dictionary, pass them to my column data source. And to get linked brushing, all I have to do is share now a data source. So when I call left.circle, I tell it explicitly, I want to pass in this data source. That's where the data should be found from. And same thing for my circle. And now notice, instead of actually passing in the literal data lists as the arguments, I pass in the name of the column. I want to take the X values from the X column in my data source, and I want to take the Y values from the Y0 case, and then the Y1 column from my data source. And so now we can see that we get 2 plots where the first plot has, X versus Y1, and the second one has X versus Y2, and so that's absolute value of X here and X squared here, and so we can see that's exactly what these 2 plots are. But more importantly, if I make a selection on one, that selection is automatically mirrored in the other, right? So we can get this kind of linked behavior very simply. And sometimes there needs to be a little bit more sophisticated when, if you have data that doesn't sort of match up one-to-one, then we'll talk about that in a second. But in the simple case where you have one set of columns that you want to generate multiple plots from, you can simply share that data source between the plots, and you can get these nice linked brushing, basically for no no cost. So, okay, so let's take a quick few minutes here and let people work on whatever of these exercises sort of you find most interesting or most useful. Again, I can come around and take a look. Mike's here; he can come around and take a look. If you have questions, just raise your hand. We'll take maybe 5 minutes or so, and let everyone here play around, and then we'll finish up with some more different interactions. Yeah. If I could just get everyone's attention back. We are getting close to the end of our 2 hours. There's a few more interesting examples I wanted to show off. And maybe we can do some exercises on those as well, just depending. So hover tools, actually, I'm a little bit remiss. I haven't actually added a hover tool example here in the notebook. So let me go to the gallery where there are some notebooks that I can show you here. Here, for instance, is this periodic table. Again, I have a hover tool, and I can drill down into all the additional columns of data that I'm not necessarily showing visually in some way, but I can show them in my hover tool. Another example with the hover tool is, I think this one, maybe? Nope, doesn't have a hover tool. Texas, yeah, oh yeah, there's a good one, right. So if we go to the Texas example, it's Texas unemployment, and so I have this hover tool. It just shows me, what is the name of the county, what is the unemployment rate, what is the lat lawn. Right now I have it so that, the hover tool follows the mouse exactly. You can actually have it snap to the sort of the center of the glyph. Even for patches, it'll actually compute the centroid and sort of snap to those very nicely. And down here at the bottom, again, you can just sort of see it's really easy to configure this. You don't even need to use the default dictionary anymore. You can just give it a tuple. I want name and the name column, and then I want unemployment rate and the rate column and percentage. Lat long, there's just this simple syntax that's described in the docs. So really easy to add hover tools. There's another one. It's also possible to customize. If I go to the user's guide and we go to, I think, styling, visual attributes, might actually be under adding interactions, now I think about it. Brushing. Callbacks for hover. Okay, it's not where I thought it was. Whoa. Turn that off. Okay, well, I'm actually not sure it is. It's possible to customize the appearance of the hover tool, right? So that's sort of a default, hover tool, but you can give it your own sort of HTML little template to show up in that hover div. So I don't have an example to show handy, but I'll at least mention that that's possible. There is an example in the examples directory in GitHub that shows that. Okay, so continuing on under interactions. Another thing to mention is IPython interactors, right? So I showed that we sort of have our own set of Bokeh default widgets that you can use, but there's also this great set of widgets that come with the IPython notebook. They're called interactors, and it's really nice. So you can actually hook those up to Bokeh plots fairly easily. So here, I'm define a plot. It's a figure. It's got a line. I'm passing in my column data source explicitly. It's got columns for X and Y. And then I define this function update. And what does that do? Well, it gets the parameters for the frequency and the amplitude and the function and the phase, and it basically just constructs a new set of data based on that. It calls the function, frequency times x plus phi and times the amplitude, and it sets that as the y data, and then it does this source.push notebook, and that's sort of the key here. And what we can see is that it actually responds to this, right? So if I let me actually go reload. So I'm getting a lot of interesting little JS errors in the notebook today. I'm not sure what's going on there, but yeah. So now if I, type float. That should be a NumPy array. Let's try that one more time. Not with a question mark. And all. It's A times. That's really weird. I'm not sure what's going on here. It's not liking something about this code, although it should just be straight NumPy, so I'm not quite sure. but I don't want to debug in the middle of, normally you can move those sliders in the plot updates, but it works sort of nicely with Python interactors. If you don't screw up defining your update function, you can update the data however you want, and then you can push it into the plot using this source.push notebook. So I'm not quite sure what's going on with my, yeah, no, we'll come back to that later. Okay, what about widgets though? I mentioned we can have these nice widgets, but again, we want to be able to have callbacks. So here's an example that does that. This is that idea that you can, if you don't mind writing just a couple of lines of JavaScript, you can actually have some rich interactions in static documents. Here, I create a Bokeh plot that shows, just a line. It's got a column data source with, X and Y, and it's just a straight line. And then I've got this JavaScript callback here, and I'm not going to go into the details here because you can see more in the user's guide, but I just want to show it off so you know where to look. Here I get my data source, I get out the X and Y data, and then I just loop over it, and I just call X to the whatever the value of the slider is. I use that as an exponent, and so you can see that when I update the slider, it updates the actual data that's viewed in the plot, right?
If you rerun 12 and 13 will work.
Okay. Weird. I have no idea what that was complaining about. It's a weird thing. I'll go back and fix it. But anyway, so here you can see. Thank you very much. So here I can select the function, and it changes the data. And so that's what that the workflow here is that it's actually computing a new set of data, and then it's calling this push notebook function to actually update the data source for the plot in JavaScript and make the plot update. Okay. So here again, I've added a slide. The way I add the widget here is I call slider, and I give it a start and a step value and maybe a title, and then I put it, in this case, I put it in this little vertical layout. But again, if you use bokeh.embed.components, you can actually embed it in whatever custom layout you want. And then it just, every time I move the slider, it calls this little bit of JavaScript, and it updates the data. So that's one example. Another example of when you can do that is with selections. So here, this one's a little bit more sophisticated, but it's a nice one to sort of see. I've got just some random data scattered. I've got this orange line drawn at the average y value, right? So whatever the mean y value is for all of the points, that's where that orange line gets drawn. And so if I make a selection, though, it switches to draw the y line wherever the average position of the selected points are, and that includes even with multiple selections, right? If I hit Shift, I can do multiple selections there. So yeah, so that's with a little bit more Java. So you can certainly do that with a Bokeh server and with Python callbacks, but then you've got to run a server. But the nice thing here is, there's a little bit of JavaScript, but it gets you kind of a lot that you can do in, again, a static document. You could email that to someone, and they would be able to interact with it and have the tools work just as I've shown here. And as I mentioned, as we discover more and more use cases, definitely want to try to encapsulate some of the more common patterns so that you could actually maybe write a callback in Python, sort of a named object in Python that sort of does most of this work for you and reduce that amount of JavaScript even further. And again, the dream one day would be to just be able to write that callback in Python and just have it translated automatically. So maybe we could use Brython or PyJS for that or something different. But if you think that's an interesting problem, then please come talk to me. I'd love to collaborate on that. So anyway, so there's some more examples in the user's guide. Go ahead and go back to adding interactions here. So you can also add interactions for hover, right? So here, this actually won't even be required to add a callback soon. We're going to add a new policy. So if you want to set the visual policy for hover, you can do that. Right now, there's a little bit of a callback to do that, but you can see as I do it does a horizontal selection as you move up and down. It hovers those points differently, so that's certainly possible to do. Here's another example of using the selection callback. All this does is it copies the data, the selected data points from the data source on one plot to another. So as I copy or as I select it, they show up in the other plot, and you can just have that sort of work without too much extra effort. So you can imagine doing a lot of interesting things with that, depending on what your JS sort of comfort level is. Last example here, show before probably wrapping up because we're getting right close to time, is it's also possible to have callbacks that get triggered when the range changes, right? So here, if I zoom in to this plot, then it actually triggers a callback that draws the box on the corresponding plot, so I can actually see, where sort of this zoom region is, and I can move that around, and it just follows around the zoom region. You can also see that level of detail downsampling going into effect on this first plot, because there's about 4,000 points in each of those plots. So that's not a huge number, but it's enough that we might want to try to make sure the interactivity is maintained. Okay, so I think that was about the last example I wanted to show. We're not going to dive into any more exercises, I don't think, but maybe we'll take a few minutes just for questions and then make sure everyone has time to get to the next session. So yeah, let's go ahead and take questions. Yep.
So just going back to the ability to create images from this, like how far do you think you really are from it?
Yeah, so the question is how far away are we from creating images? And I really hope at this point it's not more than a couple of months. There's a few different approaches. The problem is there's several possible approaches, and none of them are, or all of them have fairly significant problems. I mean, we had hoped we could maybe just run everything in Node and use like Node Canvas, which is a Cairo-backed Canvas implementation, and just pull everything out, automatically. But Bokeh is a fairly big and complicated library. We haven't gotten it to run in Node. The other idea is, well, maybe we could use we just implement a Cairo backend directly that ingests the Bokeh JSON and renders, and that's certainly doable. But building Cairo is, even with Conda, getting Cairo is maybe kind of a pain. And but that's just work. We'd have to implement enough of the rendering backend to render static plots all over again, right? So that's probably what we might end up doing. But there are some new tools. I think there are some new JavaScript libraries that didn't exist the last time we looked at this that might possibly allow us to get like SVG from sort of Canvas. They instrument the canvas and they can spit out SVG. And so maybe, fingers crossed, but then this also intersects things like that math text discussion, right? Because ideally we can draw the math text on the canvas, although what happens when a WebGL canvas enters, it's an open question. But if that doesn't work, we're going to have to absolutely position divs, and then all of a sudden your unified SVG output doesn't work. So there's all these sort of really unpleasant things intersecting. Both of those problems sort of intersect in unpleasant ways. And so we've gotten to a point where we've sort of exhausted all the other big problems we can. We've put it off as long as we can. So it is definitely a high priority for us now. And so we're going to find something that hopefully will work in the vast majority of cases for the short term. And then again, the long-term plan is to use Matplotlib. I mean, there's just been person years worth of investment into making static, fantastic static image generation and SVG and EPS and PDF and all kinds of formats in Matplotlib. So let's just leverage that. But that's we got to rely on their timeline, and they're working on some other good stuff right now, and it's going to be a while. So yeah, short answer, maybe a few months, I hope. I think I've said that before, but this time I mean it. It's definitely a priority. Okay, good question. Other questions? All right. Yeah.
What's the story with streaming?
The story with streaming. That's a really good question. So, thank you. So there's a couple of different ways to stream data into Bokeh plots if you have streaming data. So the first thing is if you have data behind some kind of REST API, and that's super simple. There's something called an AJAX data source. We saw a column data source, but there's something called an AJAX data source that you configure basically with a REST endpoint, and you can also configure it with one of these sort of JavaScript actions to do any kind of conversion you need. And you can just have that pull data directly into the client at whatever rate you want, or you can have it do it in response to widgets or whatever you'd like. And that's an easy sort of way to do it. In fact, the spectrogram example basically does something very much like that. It hits a REST endpoint, it pulls the data directly into the client, and does some work there. So that's one option. The other option is to use the Bokeh server, and you can do that today. The way the Bokeh is architected is such that when you create in Python this pile of object models that represent the visualization you want, a scene graph we call it, you can directly generate a plot from that, or you can push those up to a Bokeh server. And the way Bokeh works is that if you view a plot from the server, if the models on the server change, the plot changes, and if the state on the browser changes, it gets mirrored back to the server as well. And so that's how you can have things like selections or buttons trigger further computations on the server. And so that's really cool. You can do that now. It's a little bit maybe clunky, and so that's what we're working on, making a lot better and a lot more streamlined. And I think we have a very clear vision of where that needs to go. We just need to execute and do the work there. But you can do that now, so that's another option for streaming as well. Trying to think if there's anything other good comments to make there to point you at besides the server and the AJAX data source. Part of the server improvements we're making are more explicit support for efficient streaming. So for instance, actually doing appends. Like right now with the server, I think you have to send sort of full data columns, and that could maybe be problematic if your data is just continually growing. And so we're adding a new layer of interface, for instance, for appending data, and maybe doing that with a truncation if it's appropriate. So anyway, lots of good stuff coming. In the time being, probably the easiest way is to look at the AJAX data source. And there are some examples of the AJAX data source in the examples folder in the GitHub repo. So I'll point you at those. And certainly, any questions you have, we try to be as responsive as we can on the mailing list, on GitHub issues. We try to monitor Stack Overflow. It's gotten to be a bit of a chunk of work to monitor all that. So sometimes it takes us longer than we'd like, but we do try to keep on top of things. So, any other questions, comments? Okay. Well, I want to thank everyone for being here. Oh, sorry.
Yeah, thank you, Bryan. Thanks for that session. That's great.